Hello, ladies and gentlemen. Welcome back to our distance learning. Today we're going to talk about a new trigonometric ratio, and that ratio is called the tangent ratio. There was no reason why this couldn't have been added to our last lesson, except we generally break it up to give you a chance to digest the sine ratio, and then the cosine ratio, and now we're going to talk about the tangent ratio. Now that is the full word, tangent ratio. We are going to shorten it though, and it's going to be called tan. And remember, this A was going to represent the angle that we're talking about. So our key concepts here is that the tangent ratio compares the lengths of the legs of a right triangle, just like the sine ratio did and the cosine ratio did. The only difference is we're going to be using different lengths to make that ratio. And in this particular case, tan of angle A, now if we're going to be talking about angle A in this particular triangle, if we're talking about this being angle X, but if I want to talk about this being A, then I better call that vertice A. I can call this vertice B if I want. I can call this vertice C if I want. That means that according to this angle, that would be the opposite side to angle X or angle A. Depends how we want to talk about it, right? And this is the 90 degrees, so directly opposite it, that's our hypotenuse side, the longest side. And this was I'm sorry, I should not have gone from there. Going from here, this is beside the angle, so this is the adjacent. Now they're showing short forms to write here, O for opposite, H for hypotenuse, A for adjacent. That might get you in trouble later. I think the short form that we should probably use for opposite is OPP. I think we should probably use ADJ, and I think we should probably use hype for hypotenuse. I think those are probably better. What do we call it? Short forms for those names. Over here, now the formula is going to be the opposite side divided by the adjacent side. So I'm going to measure this side. That number will go in the top. I'm going to measure this side. That number will go in the bottom. We're going to divide those two numbers, and whatever that number is, that decimal, that's called the tangent of angle A, the angle that allowed that to be the opposite side and that to be the adjacent side. So using your calculator, example 1, first of all, we need to make sure that we're in degree mode. We talked about that quite a bit last day. So mine is in degree mode. You need to make sure, otherwise you will get answers, but the answers will look correct but are all wrong. There's 3 ways of measuring an angle. One is degrees, one is radians, and one is gradians. And remember, we're working in degrees. So make sure you're in degrees mode. The tan of 52 degrees. So if this angle was 52 degrees, if it happened to be 52 degrees, then if this side length divided by this side length would give me 52 tan, it would give me a decimal of 1.2799 to 4 decimal places, so the next number is a 4. If it was 5 or greater, I'd round up, but it's not, so I leave it with 4 decimal places. So if this was 52 degrees, whatever this length was divided by this length would equal that decimal. Now remember, that 52 degrees could be a different sized triangle. I'm going to draw on top of this triangle now. Let's see if you can see what's going on. I'm going to keep that 52. I could have dropped this opposite to be here. Now the triangle that I'm talking about is this triangle now. The angle's still 52. That didn't change, notice. But this length changed and this length changed. If I was to take the opposite from the 52 and the adjacent from the 52 and divide them, I'd get this decimal again. So even if the triangle was this size, with 52 here, I'd get this decimal when I divided those two sides. If the triangle was larger, and with angle 52, I'd still get the same decimal, even with this larger size and this larger side. And even if we made it even bigger, so let's say I come way out here now, and I come way out here now, and I make my 90 right about here. Notice this angle is still 52 degrees. I didn't change that. This is going to be the opposite side to that 52. Now this whole length is going to be the adjacent side to that 52. The amount this got bigger and the amount this got bigger are proportional, which means that this decimal will remain the same for all three triangles when we divide this side by this side, this side by this side, this side by this side. They all had 52 degrees. The tan of 52 degrees is 1.2799. I'm going to stop the video right there just so that they don't get too long, and then we'll start on the second example.